We are going to Mars. This may sound far-fetched, but in the realm of human exploration and ambition, venturing beyond our own planet has always been a captivating dream. But is it worth it? You see, one thing is to say it and write it down on paper, and another is to achieve it. And then you might ask yourself, why Mars? You see, science, with unwavering certainty, reveals a startling truth. More than 99.9% of the species that once thrived on Earth have vanished into extinction. This realization prompts profound introspection. Are we, as a species, destined to share the same fate? How did we find ourselves at this crossroads? Throughout our evolutionary journey, humanity has flourished by utilizing and inhabiting every corner of our planet. However, as our population continues to surge, we face a pressing dilemma. The available space on Earth is diminishing rapidly, unable to keep pace with our exponential growth. Concurrently, the specter of climate change looms larger, a clarion call signaling the distress of our planet. We witness the melting of glaciers, the rise of sea levels, rampant deforestation, and the tragic loss of countless species. These warnings paint a stark picture of the increasing inhospitality of our ecosystems. To find safety, we must explore other worlds. Venturing beyond our solar system offers hope, a way to escape our destructive patterns. And so many people strongly believe it's essential for humanity to embark on the quest of leaving Earth. At the heart of the matter lies a question. Can the colonization of another planet solve the problem humanity is facing, or not? First off, let's examine the challenges we face, not only on our planet, but also within ourselves, before embarking on the ambitious endeavor of interplanetary colonization. Some people believe we should not spend our money, time, and resources on this enterprise because there are problems on Earth we still haven't fixed. They argue that our focus should be directed toward addressing pressing issues such as poverty, climate change, and social inequality. To them, investing in the colonization of other planets may seem like a frivolous pursuit when our own home planet requires urgent attention and resources. Another group of skeptics questions the wisdom of colonizing other planets, fearing that we will only bring chaos and destruction to these new worlds, much like we have done on Earth. They raise concerns about the potential exploitation of resources, the introduction of invasive species, and the disruption of existing ecosystems. These individuals believe that before venturing out into space, we should learn from the mistakes of our past and strive to be better stewards of our own planet. Then there are those who acknowledge the allure of colonizing another planet, but doubt its feasibility. They argue that the challenges involved in sustaining human life on Mars or any other celestial body are insurmountable. The immense distances, harsh environments, and lack of essential resources make the idea seem far-fetched and impractical. To them, the dream of interplanetary colonization is an enticing concept, but one that is beyond our current technological capabilities. We'll talk more about this later in the video. However, proponents of Martian colonization see it as an opportunity to transcend the limitations of our world. They believe that expanding our presence beyond Earth is not just a luxury, but a necessity for the long-term survival of our species. By establishing self-sustaining colonies on other planets, we can mitigate the risks associated with being confined to a single fragile planet. It offers a chance to learn, innovate, and adapt in ways that could benefit not only our interplanetary future, but also the challenges we face on Earth. Advocates argue that space exploration and colonization have historically driven scientific and technological advancements, leading to innovations that have improved life on Earth. They envision a future where the knowledge gained from space missions and the development of new technologies can be applied to address the pressing issues we currently face. Furthermore, they argue that the pursuit of ambitious goals, such as colonizing Mars, inspires people, fuels imagination, and drives progress in ways that can have far-reaching positive impacts. You see, within each argument presented, there lies a glimmer of truth that resonates with our collective conscience. Every perspective holds some validity, urging us to reflect on the intricate fabric of our existence. By recognizing the value of these differing viewpoints, we open the door to self-reflection, gaining a deeper understanding of the complex challenges before us. One prominent figure who has captured the world's attention in the quest for interplanetary colonization is Elon Musk. With his visionary mindset and unwavering determination, Musk has become synonymous with the ambition to colonize Mars. Through his aerospace company SpaceX, Musk has set his sights on making humanity a multi-planetary species. He envisions a future where humans can establish sustainable colonies on Mars, ensuring the survival and continuation of our species beyond the confines of Earth. Musk's vision has inspired countless individuals and renewed the conversation around interplanetary exploration. Critics argue that the resources and efforts dedicated to Mars colonization could be better utilized to address pressing issues on our own planet. However, Musk believes that expanding our horizons and venturing beyond Earth is essential for the long-term survival and progress of our species. He views Mars as a potential refuge and an opportunity to push the boundaries of human exploration, innovation, and discovery. But as I mentioned before, it's easier said than done. For years now, we've been sending robotic explorers to Mars, meticulously studying its surface, atmosphere, and geological features. These missions have provided invaluable insights into the Red Planet, helping us unravel its mysteries and understand its potential for human exploration and colonization. However, as we delve deeper into the challenges that await us on Mars, we encounter a myriad of obstacles that demand careful consideration and innovative solutions. The first problem is the daunting task of transporting humans to Mars. The journey from Earth to the Red Planet spans approximately 7 months, encompassing a distance around 150 times greater than the one between our planet and the Moon. This necessitates careful consideration of spacecraft design and fuel requirements. To address this challenge, one potential solution lies in the development of advanced propulsion systems. Traditional chemical propulsion, while effective, requires substantial amounts of fuel to propel the spacecraft across such vast distances. However, innovative technologies like electric propulsion or nuclear propulsion hold promise for significantly reducing travel times and fuel consumption. Electric propulsion, such as ion propulsion, utilizes electrically charged particles, ions, to generate thrust. While it produces lower acceleration compared to traditional rockets, electric propulsion systems are highly efficient and require considerably less propellant. This technology enables spacecraft to carry larger payloads or reduce the overall weight of the mission, optimizing resources for long-duration interplanetary travel. Nuclear propulsion, another compelling option, involves utilizing nuclear reactions to generate immense thrust. By harnessing the power of controlled nuclear reactions, spacecraft equipped with nuclear propulsion systems could achieve higher speeds and shorter travel times. This could revolutionize Mars missions by drastically reducing the time spent in transit and mitigating the challenges associated with extended exposure to space radiation. Both electric propulsion and nuclear propulsion technologies are actively being explored by space agencies and private companies. Continued research, development, and testing of these propulsion systems hold the potential to revolutionize interplanetary travel and pave the way for more efficient and feasible human missions to Mars. Moreover, advancements in in-orbit refueling techniques could also play a crucial role in overcoming the fuel requirements for long-duration missions. By establishing infrastructure in Earth's orbit or utilizing resources from the Moon, spacecraft could refuel en route to Mars, reducing the need to carry all the necessary propellant from the start. This concept of in-space refueling could significantly enhance mission capabilities and open up new possibilities for sustained exploration and colonization of Mars. Moving on to the second problem that settlers will face on Mars, we encounter the formidable challenge of landing safely on the planet's surface. Mars has a thin atmosphere compared to Earth, making atmospheric entry and landing a complex and high-stakes endeavor. The thin atmosphere poses difficulties for traditional methods of atmospheric entry and parachute descent, as they are less effective in slowing down spacecraft to a safe landing speed. Additionally, Mars's unpredictable weather patterns, such as dust storms, further complicate landing operations and increase the risk of mission failure. To overcome these challenges, engineers and scientists have devised innovative landing techniques. One such approach is the use of supersonic retropropulsion. This involves firing rocket engines in the opposite direction of travel during descent, effectively creating a braking effect to slow down the spacecraft. Supersonic retropropulsion allows for a controlled descent and landing, mitigating the risks associated with Mars's thin atmosphere. Furthermore, advanced guidance, navigation, and control systems are being developed to enhance landing accuracy and reliability. These systems utilize precise sensors, computer algorithms, and autonomous capabilities to enable spacecraft to adapt to changing conditions and make real-time adjustments during descent. By incorporating these technologies, we can increase the chances of successful landings and minimize the impact of Mars's atmospheric challenges. In addition to technological advancements, extensive research and analysis of potential landing sites on Mars are crucial. Identifying regions with favorable conditions, such as flat terrains and minimal surface hazards, can greatly improve the chances of a safe landing. Robotic missions like the Mars rovers have played a significant role in scouting potential landing sites and providing valuable data for future human missions. Collaboration between space agencies such as NASA, ESA, and private companies like SpaceX is essential in tackling the landing challenge. Sharing knowledge, expertise, and resources can expedite the development of innovative landing technologies and ensure the highest level of safety for future human explorers. And then, the third issue we might face is about resources. When I say resources, I'm referring to the essential elements necessary for human survival and the sustenance of a Martian colony. These include factors such as breathable air, water, and a sustainable food supply, all of which pose significant challenges in the harsh and inhospitable Martian environment. One of the primary concerns revolves around the availability of breathable air. Mars has a thin atmosphere comprised mainly of carbon dioxide, rendering it unsuitable for humans to breathe. The limited atmospheric pressure and absence of oxygen necessitate the need for alternative methods to ensure a sufficient oxygen supply for the settlers. To address this challenge, scientists and engineers are exploring various approaches, such as the utilization of in situ resource utilization, ISRU techniques. These methods aim to extract oxygen from the Martian atmosphere or other available resources on the planet. By leveraging chemical reactions, electrolysis, or other innovative technologies, it becomes possible to generate oxygen that can sustain human respiration. In addition to breathable air, securing a reliable water supply is crucial for human survival on Mars. While traces of water ice have been detected on the planet's surface, extracting and utilizing this resource poses its own set of challenges. Scientists are researching methods to extract and purify water from Martian ice or underground reserves, exploring possibilities such as melting the ice or using heat to release and capture the water molecules. Furthermore, establishing a sustainable food production system is vital for the long-term well-being of Martian colonists. Traditional farming methods relying on soil would face significant obstacles due to the nutrient-poor Martian regolith and the planet's extreme conditions. Therefore, innovative agricultural practices such as hydroponics, aeroponics, or other controlled environment systems offer potential solutions. Hydroponics involves cultivating plants in nutrient-rich water solutions, while aeroponics suspends plant roots in a mist or air environment. Both approaches maximize resource utilization, optimize water consumption, and provide a controlled environment for crop growth. These techniques allow for the efficient use of resources and the potential for continuous and sustainable food production, reducing reliance on external supplies. The fourth challenge lies in establishing a functional base on Mars, where humans can live and work in a sustainable manner. Building a suitable habitat and infrastructure on the Red Planet poses unique obstacles that require careful planning and innovative engineering solutions. One significant challenge is the construction of a habitable environment that can shield inhabitants from the harsh Martian conditions, including extreme temperatures, high radiation levels, and the absence of a protective magnetic field. Designing habitats that can provide adequate insulation, radiation shielding, and life support systems is crucial to ensure the well-being and safety of the colonists. To overcome this challenge, NASA, space agencies, and private companies are developing advanced habitat designs and materials that can withstand the inhospitable Martian environment. These structures may incorporate innovative insulation techniques, such as multi-layered shielding or regolith-based construction methods that utilize the Martian soil as a building material. In addition to the habitat, the establishment of essential infrastructure is vital for the long-term viability of a Martian colony. This includes power generation, communication systems, storage facilities, and transportation networks. Solar power is a promising energy source on Mars as the planet receives abundant sunlight. Utilizing advanced solar panel technologies, such as lightweight and highly efficient designs, can provide a sustainable power supply for the colony's operations. Apart from the cost, which would be substantial, estimated to be in the range of billions or even trillions of dollars, there are still numerous other challenges that need to be overcome in order to successfully establish a sustainable human presence on Mars. One critical aspect is the psychological and physiological well-being of the astronauts during their extended stay on the red planet. Being away from Earth for such a prolonged period of time, isolated in a hostile environment, can have significant effects on mental health and interpersonal dynamics. Scientists and space agencies are actively researching ways to address these challenges, including psychological training, monitoring systems, and providing a supportive and engaging environment for crew members. Additionally, the long-term effects of reduced gravity on the human body are still not fully understood. Extended exposure to the lower gravity on Mars can lead to muscle and bone loss, cardiovascular issues, and other physiological changes. Developing countermeasures such as exercise protocols, specialized equipment, and medical interventions is crucial to mitigating these risks and ensuring the health and well-being of the astronauts. And finally, we come to perhaps the most daunting challenge of all: terraforming. Terraforming in this situation refers to the process of transforming the Martian environment to make it more habitable for humans, resembling Earth's conditions as closely as possible. It is an immense undertaking that requires altering the planet's atmosphere, temperature, and surface conditions on a planetary scale. The task of terraforming Mars is a monumental one. Currently, as I mentioned before, the Martian atmosphere is extremely thin and composed mainly of carbon dioxide, with no breathable oxygen. The average temperature is well below freezing, and the planet lacks a protective magnetic field to shield it from harmful radiation. Transforming these conditions into a more Earth-like environment would be a huge feat of engineering and science. One proposed solution to initiate the terraforming process is to release greenhouse gases into the Martian atmosphere. Increasing the concentration of gases such as carbon dioxide could help trap heat and raise the overall temperature. This could potentially lead to the melting of the polar ice caps, releasing water vapor and creating a more stable water cycle on the planet. The introduction of certain microorganisms or genetically engineered plants could also aid in the conversion of carbon dioxide into oxygen through photosynthesis. However, terraforming Mars is not a short-term endeavor. It would require sustained efforts spanning decades, if not centuries. The process is highly complex and involves numerous interconnected factors that need to be carefully balanced and monitored. Scientists and researchers are conducting extensive studies and simulations to better understand the implications and feasibility of terraforming Mars. Despite the enormity of the challenge, the idea of transforming an entire planet to make it habitable holds great allure and serves as a testament to human ingenuity. While the full-scale terraforming of Mars may still be a distant dream, it fuels our imagination and inspires us to push the boundaries of scientific discovery and innovation. In the pursuit of colonizing Mars, it is crucial to recognize that the journey is not solely about finding a new home for humanity. It is an opportunity to learn more about ourselves, our place in the universe, and our capacity for exploration and adaptation. Even if the challenges seem insurmountable at present, the collective efforts of scientists, engineers, and visionaries pave the way for potential solutions and advancements that can shape the future of interplanetary colonization. You see, colonizing Mars is more than just understanding whether life existed elsewhere in the universe. It's driven by our innate desire to push the boundaries of human exploration, challenge our limitations, and leave a lasting mark on the cosmos. It represents a profound leap towards securing the long-term survival and expansion of our species. The exploration and colonization of Mars hold the potential to redefine our place in the universe and to become a multi-planetary civilization capable of withstanding the uncertainties that the future may hold. By establishing a sustainable presence on Mars, we can safeguard the continuity of humanity, mitigate the risks of global catastrophes, and ensure the survival of our collective knowledge and achievements. Moreover, Mars colonization represents an unparalleled opportunity for scientific discovery and advancement. Unraveling the mysteries of Mars can shed light on the origins of our solar system, the evolution of planets, and the conditions necessary for life to emerge. It presents a unique laboratory for studying planetary geology, atmospheric dynamics, and the potential for habitable environments. Each scientific breakthrough on Mars has the potential to reshape our understanding of the universe and our place within it. As we gaze toward the future, the question of when we will embark on the grand endeavor of colonizing Mars lingers in our minds. While concrete timelines remain uncertain, the collective efforts of scientists, engineers, and space agencies around the world are gradually paving the way for this extraordinary feat. Incremental steps, such as robotic missions, technological advancements, and extensive research, are laying the groundwork for the eventual human presence on the Red Planet. However, it is crucial to approach the notion of Martian colonization with patience and careful consideration. The complexities involved in establishing self-sustaining habitats, ensuring the well-being of future settlers, and navigating the inhospitable Martian environment require meticulous planning, innovative solutions, and rigorous testing. It is through these deliberate steps that we can mitigate risks, optimize efficiency, and enhance the chances of success. While the challenges ahead are formidable, so too is the human spirit. Our journey to Mars represents the culmination of generations of dreamers, thinkers, and pioneers who dared to imagine the impossible. It is a testament to our relentless pursuit of knowledge, our capacity for resilience, and our innate curiosity that compels us to push the boundaries of what we can achieve. Well, that's it for this exploration into the challenges and possibilities of colonizing Mars. Throughout this journey, we've delved into the complexities, debated the arguments, and pondered the future of interplanetary exploration. The key thing to take away from this discussion is that the quest to colonize Mars is not a simple endeavor, but a multifaceted and captivating pursuit that raises profound questions about our place in the universe. Thanks for watching, and I'll see you in the next one.